we're going to look at solving polynomials graphically. And at a problem, it says the function f is defined as f of x equals x cubed minus x squared minus 6x. Solve f of x equals 0. So I want you to pause and think about, what is this question asking me to figure out? Hopefully, in thinking about this, you honed in on this last section here, which says solve f of x equals 0, meaning when will this function equal 0? So what the question is asking us to find is when x cubed minus x squared minus 6x will be equivalent to 0. In other words, well, where is something equivalent to 0? What does that look like on the graph? That's, of course, and you're answering this, I'm sure, in your head, that's where it intersects the x-axis, also known as the roots or zeros. Okay? And we have some different methods for finding this, and what I want you to do is I want you to stop and think about what would be your plan B for figuring out where this function is equal to 0. So in thinking about it, there's a lot of different ways, and I'm sure your way would work just fine, and I want to focus on a particular method, which would be to simply graph the function. So I'm going to graph f of x, and then after I've graphed it, I want to see where it equals 0, right? Where it hits the x-axis, and those will be my points. So that's going to be my plan. So in order to graph my function, I'll go ahead and create a graph for myself here. In order to graph the function, a polynomial, what are the things that we need to know? I want you to make a list. Well, we need to know the basic shape, and we also need to know the roots and how the function acts at the roots. So let's start with the basic shape. This is a cubic polynomial, so it'll have this serpentine look. It will rise to the right and decrease to the left. So we know the basic shape, and we also need to know the roots. And so this might be a little tricky. How are we going to find the roots of this function? And there are, it's not a quadratic, so we can't use the quadratic formula. What are the things that we have worked with which are linked to the roots, which will help us understand the roots? And those things are the linear factors. Can we find the linear factors of this polynomial? So I want you to pause and I want you to try for a minute, see if you can factor our polynomial to find the linear factors. All right, I hope that went well. This is actually a little tricky. We've done this a few times, but you'll notice that we don't know any of the linear factors to start off with, so we can't use the division algorithm to find the remaining two. But what we can do is we can think about pulling out a common term from each, common factor from each term. And in doing that, we'll be able to factor. So we have x cubed minus x squared minus 6x, and what we can do is we can pull out an x. So I'll have x times x squared minus x minus 6. Notice all I did was factor out an x. So now I would have x times x squared, give me x third, so on and so forth. And now I'm left with x, and is x a linear factor? It certainly is, right? This is to the first power, so it's a linear factor, and this is a quadratic. So how many linear factors will this give me? It will give me 2, and that's exactly what I'll expect because this is a cubic, so I should have 3. So I can go ahead and factor that quadratic, and I'm going to end up with x minus 3 times x plus 2. All right, so now I have all the linear factors, which means I also have the roots. So I'm ready to go ahead and graph. The first root from that factor of x is just going to be at 0. The second root, x minus 3, is the linear factor, which means to make that 0, I need to be at positive 3. And then the last linear factor is x plus 2, so there will be a 0 when x is negative 2. What will happen at each root? Will it bounce off the x-axis or will it go through? And since all of these have degree 1, we know that they're going to change sign at each root, and so it's going to go through. So if I were to graph it, looks something like that. And so now we have the graph, and if I look at my plan here, I've graphed it, and I want to see where it is equivalent to 0. Where is my function equal to 0? And that, of course, we made a note here, is where it hits the x-axis. So I'm sure you can go ahead and find those points. So why don't you go locate where it hits the x-axis. It hits the x-axis when x is equivalent to negative 2, when x is equivalent to 0, and when x is equivalent to 3, right? All of those points. All right? And so now we have a kind of a good baseline for what it means to solve and to look for where a function is equal to some value. So now let's come down here and let's try this. So we want to solve when f of x is equal to 5. So let's just go ahead and clear a little space here. We'll keep our graph because we've already graphed it. And what we're asked here is when our function x cubed minus x squared minus 6x is equivalent to 5. And this is a little harder to think about, right? Because instead of saying equal to 0, we know 0 is the x-axis. Where is 5? Where would that be? And so it might be good to actually kind of think about this. Let's just say that 5 happened to be right there. Well, then we're asking where is our function going to intersect that line? Where is x going to intersect the line y equals 5? Where is that going to happen? And it looks like it should happen, definitely should happen, somewhere past 3, right? This is 3. It should definitely happen somewhere past 3. And is there anywhere else that it could happen? I want you to pause and think about this. You should notice that in between negative 2 and 0, it's positive. Do we know exactly what value it is? I just arbitrarily put 5 there. 5 could be down here. I'm not quite sure yet. I know that it will for sure hit somewhere past 3, but it looks like it could also hit somewhere between negative 2 and 0. And so how are we going to figure this out? Okay, how are we going to figure that out? Well, the method that we're going to do is we're going to try and make some educated guesses using our graph, and we're going to create a table to see if we can organize our values to figure out if there's a place that it's 5 or gets really close to 5. Okay? And I want to think about how we'll know if if it's going to hit 5 somewhere. Imagine if we're right here, and if we find the point just below 5. And then we skip ahead, we try another point, and we get to a point right above 5. So maybe it's 4.9, and then right here we have 5.1. Somewhere in between, it has to have hit 5. So I can make a really good guess. If I never am able to get below 5 and then greater than 5, I know that, hey, unfortunately, I'm just not going to be able to reach my desired value. So let's go ahead and make a table of values here. So on the left, I'll have my x value that I'm looking for, that I'm going to try, and on the right, I'll have my f of x value. So let's go ahead and start, and I know this might seem counterintuitive, but let's start where we know for sure it's going to intersect 5 at some point, because past 3 it will continue to increase, so it's got to at some point hit 5. So let's pick a value that we'd like to try out. So pick one for yourself. I bet a popular choice was 4. So I'm sure a lot of people chose 4. And what I would like you to do is go ahead and try 4. So plug in 4 and see what you get. When you do that, you're going to end up getting a number that's a lot bigger than 5. So if you plug in 4 for x, you're going to get 24. Way too big. Okay, way too big. So let's go ahead and try something smaller. Pick a value in between 3 and 4, right? You know 3, let's just put it back up here. At 3, it's at 0. So we're looking for where it is equivalent to 5, right? Where does it intersect that line? So we'll pick another value. Let's say 3.5. So you try 3.5, and what do you get? Well, when you plug in 3.5, you're going to get 9.6, I believe. So that's still too big. You get 9.6. So now let's try some smaller values. And at this point, you may say, okay, well, let's keep splitting the difference. Let's try 3.25. So if you plug in 3.25, and I plug in 3.25 here, 3.25 cubed minus 3.25 squared minus 6 times 3.25, I'm going to end up getting 4.27 or so. So now I'm below. So when I plug in 3.25, now I'm below. I'm at 4.27. Okay, so we're getting closer. What I want you to do is I want you to go ahead and pause the video. I want you to keep trying values, going back and forth until you're satisfied that you're very, very close to 5. All right, so the next value that I would try is something a little bigger than 3.25. I might try 3.3. And when I plug in 3.3, I end up with 5.24. Great, so I've narrowed it down, right? I'm now in between, somewhere in between here, there's got to be my missing value of 5. Somewhere in between 3.25 and 3.3. So you can keep trying values. Maybe you try 3.275, and when you plug in 3.275, you're going to get a value that's very, very close to 5, 4.75, and you could keep trying values and keep whittling it down and getting closer and closer and closer and closer and closer. And what you might find is that you may never quite get there. You might keep bouncing above and then below. For example, if I plug in, this will be the last one we'll try, if I try 3.285, the value that I will get when I plug that in is 4.94. 4.95, I guess, if you round it, 4.947. And so now we know that somewhere in between these two numbers, these two x values, somewhere in between there is where it intersects at 5. And so we can make an approximation at this point. The approximation, I might just use this as my approximation. Or I might say something slightly greater than when x is 3.285. Or you could try 3.29. And you might find 3.29 is even closer. And you might want to go with 3.29. But our goal is to get as close as we can without spending too much time. Okay, so why don't we just call it 3.29. So we'll say when x is 3.29. All right, but we have one other spot, right? We didn't check between -2 and 0. So we can go ahead and make another table here. Let's try, here's x, here's f of x. And we want to know, in between -2, it's -2 at 0, and at 0 it's 0. So somewhere in between here will I be able to reach 5. And I want you to try this on your own. I want you to try some values. Perhaps start with plugging in -1. And when you plug in -1, you're going to find that you get 4, right? -1 cubed minus -1 squared minus 6 times -1, you're going to get 4, okay? And I want you to try some values on either side and try and determine whether or not you can actually get to 5. All right, hopefully that went well. What you'll find is that you can never actually get to 5. It's going to hover around 4, but it'll never quite get to 5. And so we're going to discount this part. It's never going to reach 5 there, and we're going to go say our only approximation is when x is about 3.29, and I can use this squiggly equal sign here. That tells me that it's about 3.29. Go ahead and answer the question above, explaining how you can use a graph, and then write down 2 questions you still have.